Okay, let's talk about April 13th, 2026. This was the day NVIDIA made an announcement that didn't just, move the goalposts for AI. No, they tore them down and built a whole new stadium. They unveiled something called the Hyperion architecture. And trust me, this is a moment that's going to completely change the future of computing.
But to really get why this is such a revolution, we have to start with a pretty wild question. What if AI's biggest enemy, the one thing holding back all its incredible potential, is something as simple, as ancient, as a plain old copper wire?
So here's the deal. AI has been growing at this insane, exponential pace, right? But it's run smack into a physical wall. For years, we've just been building bigger and bigger models, but we keep hitting the same barrier, a great wall, you could say, made of metal. And it's creating a serious crisis in the world of computing.
And that's where we get to the heart of the problem, something called the Copper Bottleneck. For decades, copper wires have been the go-to for connecting processors. It's just what we did. But now with these absolutely massive AI models, AIs that can actually act and make their own decisions, and data centers packed with millions of GPUs, copper has become the ultimate choke point. It just can't handle it. It generates way too much heat, it guzzles energy like crazy, and honestly, it just can't keep up anymore.
Yeah, to put it really simply, our ideas for AI are growing way faster than the wires that connect it all. It's become a literal race between what AI could be and the physical limits of the stuff we're building it with.
So how in the world do you solve a problem like the copper bottleneck? Well, NVIDIA's answer is, it's just brilliant. The idea itself is pretty simple, but pulling it off, unbelievably complex. They just decided, you know what? Let's stop using electricity to move data, and let's start using light instead. And this really lays it all out, doesn't it? Look, on one side, you've got electrons in copper. That's the old way. They get super hot, they use a ton of energy, and they're pretty much maxed out on speed. But on the other side, photons in silicon. We're talking almost no heat, a tiny fraction of the energy, flawless data transmission, and, well, it travels at the speed of light. This isn't just a little better, it's a whole new ballgame. So what's the magic trick here? It's a technology called co-packaged optics, or CPO for short. See, normally you'd have all these separate parts to turn electrical signals into light. What NVIDIA did was build the optical engines directly onto the GPU. It's all in one place now. This means data is basically born as light, right at the source, exactly where you need it.
All right, so that's the how. Now for the really fun part. Let's dig into Hyperion's superpowers, because the numbers we're about to see are, frankly, they're staggering.
Okay, let's just start with this monster of a number. The special switch that works with Hyperion can handle 409.6 terabits per second of bandwidth. Now, what does that even mean in the real world? It means you can connect these huge clusters of GPUs and get them all to act as one, like a single, gigantic, unified brain.
And then there's the energy savings. Just look at this. The last generation, the Blackwell architecture, was using 30 watts of power for every port. Hyperion? It gets that all the way down to just 9 watts. That is a 5 times improvement. Think about what that means for a massive data center. We're talking about saving an absolute fortune on power bills and cooling. And it's not just about raw speed either. It's about responsiveness. By putting those optical engines right on the chip, Hyperion just demolishes latency. That's the little delay it takes for data to get from point A to point B. It cuts it by a whopping 80%. That makes everything, faster and way more efficient.
Now, with all this incredible power, there's a new requirement. You have to use liquid cooling. And this isn't just some fancy add-on for enthusiasts. No, it's absolutely mandatory. It's the only way to keep these super dense photonic parts stable. This is just the new standard if you want a top-of-the-line GPU.
Okay, so all these specs and numbers are seriously impressive, right? But you're probably wondering, what does this all actually mean for the future of AI? What does all this power really unleash? This is why it matters so much. First off, this technology lets us train AI models that are just unbelievably huge. We're talking models with over 100 trillion parameters, and we can train them in record time. Second, it makes the data centers, the AI factories as they're called, 10 times more resilient. That means less expensive downtime when things go wrong. And finally, and this is a really big one, it drastically slashes the energy waste and the carbon footprint of the supercomputers that are going to be powering our future.
You know, it's so important to get this. Hyperion isn't just another small step forward. This is not just a slightly faster chip. What we're looking at here is a fundamental shift in how we think about computing.
It's truly the dawn of a whole new era. And honestly, NVIDIA said it best themselves in their announcement. The quote was, "This is the passage from the era of the electron to the era of the photon." Just let that sink in for a second. We are fundamentally changing the thing we use to compute, swapping out electricity for light.
And all of this brings us to one final, pretty provocative thought. With this monumental leap forward, NVIDIA isn't just strengthening its lead, it's basically rewriting the physical rulebook of computing. So as we officially step into this new photon era, the big question is NVIDIA even catchable anymore?